Imagine you're looking at a friend of yours and see two of him there in front of you. One is your friend now, and the other is your friend as he appeared to look more than a year earlier. Could something like this really happen? Definitely. If you gaze at the Big Dipper when it's highest in the spring, you'll see that it's oriented upside down, as if any water in its bowl would spill downward onto the North Star. At this time, if you visually draw a line from the upper right bowl star Phad to the upper left one Merak, and then extend it an equal distance, you get to a bit of blank sky, where large telescopes show a curious pair of dots. This is the double quasar, whose official name is the poetically lilting QSO 0957 plus 561. Quasars are the super brilliant active nuclei within some galaxies. When the universe was younger, intense starbursts popped off in galactic centers as matter swirled around supermassive black holes, making their nuclei much brighter than the rest of the galaxy. When viewed from distances of billions of light years, they show up as dazzling pinpoints, while the rest of the galaxy remains invisible. Because they seem like quasi-stellar objects, they're anagrammized as quasars or QSOs. Quasars don't exist anywhere anymore. The ones that we see now are ancient specimens whose light is still en route to us from distant empires. In the case of QSO 0957 plus 561, the quasar is located 7.8 billion light-years away, a whopping 2/3 of the way to the edge of the observable universe. This alone makes it interesting. Except that this quasar isn't one object, but seems to be a pair of them. Or is it? Astronomers using spectroscopy determined that both show precisely the same fingerprint. They are one and the same. A massive foreground galaxy, unseen in most images of the quasar so far, has bent space and forced the quasar's light to take two separate routes to reach us. These individual light paths do not travel side by side, but manage to ride on highways routed on different sides of the foreground galaxy, so that one travels a bit extra mileage. Thus, any flickering or change in one image of the quasar is followed by the same change in the other image 417 days later. Quasars can outshine large galaxies, though their brightness may fluctuate every few days, weeks, or months, depending on how much matter they're gobbling up at the time. Because of this finicky eating schedule, a double quasar may appear to jiggle in space when one member of the pair brightens or dims, while the other remains static. With the help of the Gaia Space Observatory and Sloan Digital Sky Survey, the study authors targeted several jiggling quasars in the distant universe and then zoomed in with the Hubble telescope. The team that discovered this quasar noticed that the two quasars were unusually close to each other, and that their redshift and visible light spectrum were also very similar to each other. They published their suggestion of the possibility that they are two images of the same object formed by a gravitational lens. The twin quasar, therefore, was one of the first directly observable effects of gravitational lensing, which was described in 1936 by Albert Einstein as a consequence of his 1916 general theory of relativity, though in that 1936 paper he also predicted, of course, there is no hope of observing this phenomenon directly. His theory very basically states that light rays change direction when passing near a massive object. The positional shift of a star in Taurus during the 1919 total solar eclipse confirmed this theory. When the geometry is just right and the foreground lensing of the object is huge, as when a major galaxy of hundreds of billions of stars is doing the warping, we might observe a ring, arcs, or multiple images of the same distant objects as it travels to us past this intervening mass. In April 2021, NASA scientists discovered a rare double quasar in an ancient corner of the universe. Researchers have said that finding this heavenly body was like finding a needle in a haystack. In a new study, astronomers used NASA's Hubble telescope to peer 10 billion years into the cosmic past, where they detected two gargantuan quasars on the verge of colliding. Sitting at the centers of their respective galaxies, these hungry quasars have less than 10,000 light-years of breathing room between them, putting them far closer to each other than the Sun's Earth is to the center of the Milky Way, about 26,000 light-years away. To ground-based telescopes, the quasar neighbors look like a single object, and one day, thanks to the unstoppable collision of their home galaxies, they will become one. So, when you're looking at a quasar, you will be hit with questions. Which one is the real body and which is the echo or the phantom? The answer is neither. They are both the same quasar. Thank you for reaching the end of this video.